Howdy folks, we're on to week 3 here. We're almost getting caught up now. Should be on track coming up next week, hopefully, if everything goes well here. So we're looking at our hands-on programming in R, chapters 4 through 8. This is the playing card section this week. So we're just jumping right in, having lots of fun with it. There's a lot going on here, and a lot of what we're going to be looking at with the content this week is how do we manage multiple lists of data, or multiple vectors of data, or essentially we're going to turn things into data frames. That'll be the nice way of handling these things. We get a nice little table. So if you imagine tables in Excel, if you're familiar with those, right? We get rows and we get columns. So we're going to specify what our columns are, and they'll have specific types, and then we'll have rows of data that represent something across that table, which is really cool. So like an instance. So as we're doing our playing cards, we're going to set things up so we can have the face value, we can have the suit, and then we can have the value of the card so we can use it in our games. And it'll be a lot of fun. So we'll be getting into that. So the first thing I want to do is start up a new R project here. So I'm going to do a new project. And I'm going to do in a new directory here, new R project here, and I'm going to make sure I put it in my GitHub repository for the class, so all that code will go out there for you so you can check it out later. I'm going to make a new folder in here. Let's make a new folder for week 3. We got our week 3 folder. Oh, no, I didn't even need that. Too far. Too many folders in here. That's right. This will make the folder week 3 for me, so we can make a project. And then we'll have everything we can save here, we can keep our environment clean, and everything will be nicely organized in week 3. Should work out pretty well for us. So first thing we're going to look at is the idea of how we can look at vectors. Right? So we kind of take a step back and let me pull this one up here. Looking at how we can build out our deck in objects here. Right, which is pretty fun. Eventually we'll get into some saving cards here. We'll get some notation, modifying values in our environment in this set of chapters here. So eventually we'll get something that looks similar to this Excel table, right? This idea of that spreadsheet. We've done our vectors before, so we were doing with sandwiches, right? I think was the example here. So we're trying to do some different ones than what's in the text here. So when we look at how do we build these out, right? We can have a single set here. And again, they're vectors, so this is the single one-dimensional vector. They all hold the same value, and there's cool stuff about all the different types that you can have in here. If you want to deal with integer values or doubles, or if you're getting into the characters or strings here, or logical types, trues and falses, complex values, which we're just going to say, hey, that's cool, and then raw values, again, hey, that's neat, but we're not going to touch them here. It's nothing we want to get into. So as we're looking at working with our data, attributes are some useful piece of data about the data. That's the metadata there. So we can set names for things in our values as we see what they are. Right? So we can give sort of that data about the data here. And it's just add some names. So you assign a vector of strings here as the names of something. So the names of your object that we created. And we'll set that up for you so you can see what the attributes are of your values, which is kind of cool. So when you print it out, you can see, hey, this is what's going on in here. But just because they're names, right, they're not really attached to the data as we go. So you can also reorganize these things with the dim here. So we can say, hey, I want to take my vector and I want to turn it into a 2-dimensional vector here, an n-dimensional array. And really, n dimensions gets a little nuts here. 2 dimensions mostly make sense to us, right? That's pretty easy. Rows and columns. We can sort of imagine 3 dimensions, right? You have rows and columns and like layers of a cube sort of there. After you get beyond that, it's a real big headache and not really worth spending a whole lot of time on, because we've got other ways we can store data as well. So you might be familiar with matrices, depending on how much math you've done before. So you can make matrices as well. Now, you can tell matrices how many rows you want, and you can tell it how you load the data. So typically when we load our data here, we're going to load by column. So it'll load the first column first, and then it'll load the next column with the next set of data. So if you want it to load by row, you can tell it, hey, let's load by row, please, and you'll get your data across the row first. So our arrays, again, you can turn these into this n-dimensional. So we're going to have 2 rows with 2 columns and 3 layers. Right? So you get rows, your columns, and then your layers, or your along that cube here. So we're going to see, hey, we get our first bunch of values here, and it's going to put them in that first layer by column, and then we go to the next layer, and then we're in 21 to 24, the next by column, and then the next layer, 31 to 34, by column in here. So we can make lots of different layers as we go, depending on how we want to order our data. So we can build things out pretty well. Now, the class of these types here, right, is matrix, because we've said, hey, this is this two-dimensional value for us here. Dates and times are fun. There's some interesting stuff about how we save dates and times. Integer values are pretty nice for doing these things, or doubles really, because they need to be big numbers. The number of seconds from January 1st, 1970 in UTC, which is super fun. So that's just one way of storing time. Turns out it'll be a problem, a bunch of years from now. I think in like 30 something, we run out of time in the Unix system and overflow most integers, but that's a problem for later. We don't need to worry about that right now. And you can find out the actual number of seconds if you want with some of these cool commands. So factors are a great way that we can take categories and turn them into numeric values so they're easier to store. So it turns out behind the scenes, storing characters is actually bigger. It takes a little bit more time, a little bit more memory. So one of the things we can do is we can store them as factors, where we're going to store integer values and then have this sort of map and say, hey, I am going to have a list of values here. So if I have male and female, female and male, so there's only two different types here. So we can actually turn them into this integer value now with this factor. And we can see it automatically builds out attributes for you. So we can say, hey, here's the attributes of male and female, and then we have the class here. And then the actual data is 1 or 2. Right, because we have two different factors. Is it the first value or the second value in the attributes list here for that, which is kind of fun. So a lot of times R wants to turn things into factors because it likes to store data that way, but we don't have to do it that way, but a lot of times it'll do that for us automatically. So if we're looking at trying to build out a card, right, we can say, hey, I want a set here of ace, hearts, and 1, because that'll be the value of the card here, but you'll notice it turns it into a string. Right? The way that we deal with our vectors is they only can have the same type of data. So if we have characters here, then they will all be treated as characters. So we have to be a little bit careful on how we do that. And R is kind of fun. Everything really eventually will turn into a character, depending on how hard you try here with this coercion. So you can take all these things and turn them into characters if you want. Really, it stores them as numbers, so you can like turn in get the sum of trues and falses, which is kind of fun. You can look at the types here. So false is a 0, 1 is true, like depending on how you look at your data here, right? The value 1, number 1 as a character, and you can turn to that. You can turn a integer here into logical here, so anything non-zero, or false is a 0 for us. So we can do lots of fun things. So if you want to have different types of data, that's where we start using this list idea. So lists don't have to have the same type of data, which is really fun. So you can get kind of messy though. So this list here has the first value is another vector here of 100 to 130. Right? So you see all the values here in the first item in the list. The second item in the list has a character here of R, and the third value in the list has another list with two values in it of true and false. So the third value, first item, the third value, second item, false. So it gets to be a little messy when we're using lists. So we could build out lists to make cards here, and it could work for us. It's not really what we want to do though. So the better way of doing this is data frames. So we'll pause for a minute, and then we'll pick it back up in the next video.